Okay, in Unit 1, Objective 3, we are looking at piecewise functions. And so up at the top here, you have a quick little reminder about the 4 function families that we've looked at so far. This would have been last week in the function family review. We have our linear here, our linear absolute value. Both of these have a slope of m, and then their starting point, right, that zeroes out the x and the y components, starting point of hk. We then also have our quadratic, which similarly has an HK starting point, and then it has a stretch of the A, and remember we always do A over 1 to help us get those points on either side of the vertex. Okay, and then there's the exponential function, which is, for most students, usually the one that's the trickiest of the bunch. HK still exists here, H canceling out the x component, K canceling out the y component. But remember, your HK for your exponential is your asymptote. And then there are a variety of ways of finding the remaining points. But as we've talked about several times, most people use an XYT chart for a couple of additional points to help with their graph. Okay? And so as a quick reminder, piecewise functions then, the reason we want to make sure that we have these 4 functions in our head is because piecewise functions are made up of pieces of these other functions. A piecewise function is a little bit like a rag doll. Where you take, a bit of this fabric and a bit of that fabric and a little bit of this other fabric, and you stitch it all together, and so you get this doll that is made up of different pieces of different fabrics. A piecewise function similarly takes a little component from maybe a quadratic and a little component from a linear and maybe an absolute value, and then stitches it together to create a function that has little individual pieces of each of those other ones, right? Now before we get into graphing our piecewise functions, we do want to take a quick moment and just look at reading a piecewise function. And so that's this first part here. A piecewise function is defined on a sequence of intervals. And so we're going to look at what this means with the following example. Given the piecewise function below, evaluate each of the following. Again, a piecewise function is defined on a sequence of intervals. If you look at this piecewise function here, you notice we have a quadratic and a linear. And the quadratic exists as long as your x is less than 3. If your x is not less than 3, then that quadratic does not exist for this particular piecewise function. This quadratic only exists as long as your x is less than 3. Similarly, this linear only exists if x is greater than or equal to 3. If your x isn't greater than or equal to 3, then this linear does not exist for this particular piecewise function. Only when your x is greater than or equal to 3 do we use this linear function. Okay? And so we're going to evaluate these 4 values using that concept. And the reason we want to start here is because of what we've talked about a couple of times, which is when all else fails, when you are looking at a function and you're sitting there going, man, I don't remember how to graph this exactly. Your best friend in that moment is going to be an XYT chart, plugging in points and seeing what you get. Now with a piecewise, if you're going to go that route, you're going to have to plug in quite a few potentially. But it's a good strategy to keep in mind when you are sitting there going, oh, I'm not sure. And so if you're going to use an XYT chart, you better make sure you know where the numbers get plugged into. Okay? So I'm going to do 2 here, and then my recommendation is going to be to pause the video, try the next 2 on your own, and see what you get. Restart the video when you have your answer, but I obviously will leave that up to you. Okay, so with A here, if we want to figure out what f of 0 is, so 0 is my x, and if I wanted to take that, because maybe I'm doing an XYT chart, and plug it into my equation, I need to know, do I plug it into the quadratic or do I plug it into the linear? Okay, well it all depends on how 0 falls in these 2 intervals. In this case, is 0 less than 3? Or is 0 greater than or equal to 3? And in this case, 0 is less than 3, and so I'm going to plug 0, because it's less than 3, into the quadratic. And so I'm going to be doing 2 times 0 squared plus 1. which is, simplifying that, 2 times 0 plus 1 is 1. I don't use the linear at all because 0 does not fall in this interval of x is greater or equal to 3. 0 is less than 3. It falls in this interval, so I'm going to use the quadratic. Okay, let's do another. Plugging in 5, which interval does that fall in? Okay, well, f of 5, I should say, falls in greater than or equal to 3, right? 5 is greater than or equal to 3. So I'm going to use this bottom function of negative 4 times 5 minus 2. 5 isn't less than 3. If I plugged 5 in here, that's not true, right? 5 is not less than 3, and so I'm not using the quadratic. 5 doesn't exist in that interval, and so the quadratic doesn't exist at x equals 5 for this particular piecewise function, right? Only the linear exists at x equals 5 for this particular piecewise function. And so then we have negative 20 minus 2, which is negative 22. Okay, again, my recommendation is to pause it at this point. Try the next two on your own. Restart it when you're ready. Or maybe watch one and then pause it. Try the last one on your own. Okay, f of 3. Which one am I plugging into for f of 3, top or bottom? Okay, well in this case 3 would be the bottom, right? 3 is equal to 3, and so I'd be plugging it into this function here. Negative 4 times 3 minus 2. 3 isn't less than 3, and so I'm not using the quadratic. This is negative 12 minus 2, which is negative 14. Okay? And then f of negative 2, which one am I using for negative 2, top or bottom? For this one I'm using the top, right? Negative 2 is less than 3, and so I'm plugging it in here. 2 times negative 2 squared plus 1, which is 2 times 4, or 8, plus 1, which is 9. Okay? Okay, again, if there are questions on this, write them down now, or maybe email your teacher if you don't want to wait till class, because we are going to continue to use this idea periodically. Okay, the last bit of this particular set of notes here is graphing then, and we're also going to make sure we review domain and range one more time. And so with number 2 here, I'm going to walk through number 2, kind of give you an idea of what we're doing with the piecewise function. And I'll do a couple before I'm going to recommend that you potentially pause the video and try it on your own. Okay? So with number 2 here, we have not as much a piecewise, it's part of a piecewise, right? We have a function here that lies between 1 and 4, not including 1, but including 4. Okay? And I'm going to come back and talk about what I mean there in a bit. But we have our absolute value here that we're going to graph. Okay? Now again, there's a couple of different ways of doing this. You can do an XYT chart, but I'm going to graph here like an absolute value. So let's go ahead and turn this into its descriptive form, subtract the 1 over to the other side. And what would your starting point be? Well, your starting point would be 2 for x and 1 for y. And then we have a slope here of 1. Okay, for some people, they're going to be able to take this and look at this region and know exactly what to graph. And I will walk through how to do that in a short bit. For others, you might never reach that point. You might always start with graphing the absolute value as a whole and then erasing everything except what is included in the given interval. So I'm going to demonstrate that first. Okay, so let's go ahead and graph the absolute value we've now identified the parts of. 2, 1 for a starting point. And if you're going to do this, draw light because you're going to erase some stuff. 2, 1 for a starting point, and then a slope of 1. So up 1 over 1 in both directions. Okay, and I'm not going to go super far. I can go further if I need to expand this, but I'm going to go ahead and stop there for now because again, I'm remembering I'm probably going to be erasing some stuff. Okay, and there's your absolute value. Now here's where the interval comes into play. Okay? When we learned domain and range, we talked about why we would do a no equals versus why we would do an equals. Why do we do an equals in our inequality? Okay, we do an equals when there is a point, right? It's why we never use equal on negative infinity or infinity, because you can't put a point at negative infinity or infinity. You can't reach it, right? So we never put an equals there because we can't put a point. Versus a no equals, which tells me there's no point. It's why we always use a no equals on infinity and negative infinity, because there's no point there. Okay? And then the only part of my graph for this absolute value is what occurs between 1 and 4, with no point at 1 and a point at 4. Okay? And so all this stuff out here, which isn't between 1 and 4, I'm going to erase that, right? Because my graph only exists between 1 and 4, and I'm going to put no point at 1. A hole. And then my graph is going to go from there until I get to 4. So we're at 2, 3, 4, at which place I am going to put a point. And then the rest of my graph doesn't exist. Okay? That's how we do a piecewise, or at least a part of a piecewise. Okay, and then domain and range, so that we can practice that a bit. Domain are my x values, and we're going to do them in interval notation. So my x values start here at 1 and go to 4. There is no point at 1, so I'm going to do a parenthesis, but there is a point at 4, so I'm going to do a bracket. Okay, and then range my y values. My y values, the lowest one is at 1. The highest one is at 3. And there's no break in between, so I'm going all the way from 1 to 3. Okay? And there are points at both y equals 1 and y equals 3, so I'm doing brackets on both values. Okay. Okay, let's do a couple more together here. I'm actually going to bounce around a little bit, although I'm going to start here with number 3. Okay, so let's go ahead and take a look at number 3. For f of x equals 2 to the x minus 3 if x is less than or equal to 3. Okay, so let's go ahead and start with graphing our function, turn it into descriptive form. What does that mean we're going to do? Okay, we're going to add 3 to the other side. And so then pulling out my starting point, which remember for an exponential is the asymptote. Where's my starting point? Okay, well, x would be 0, y would be negative 3. Okay, and remember I'm doing that light because I might end up erasing some of it. So let's go ahead and start with my asymptote here, 0, negative 3. And then an x, y, t chart, what other 2 points are you going to plug in? Okay. Well, I'm going to plug in 0. I'll plug in 1. And you know what? I'm going to plug in 3. I would probably recommend plugging in 3 just because that is where we are starting or ending our interval here, right? It's a value that for some reason this piecewise has decided to be concerned with, and so I'd probably plug in 3. And if it bothers you to have just 3 and not a 2, maybe you do 2 and then 3, right? Again, it's usually helpful to include the given points already. It's why I use 0. It's one that's already found, right? I like using 0. But the other one, when I am given another x value that I use, I do usually use that x value. And maybe you find the ones in between, maybe you don't. Okay? Plugging it in, we get 2 to the 0 minus 3, which is 1 minus 3, or negative 2. Plugging in 1, we get 2 to the 1 minus 3, which is 2 minus 3, or negative 1. Plugging in 2, we get 2 squared minus 3, which is 4 minus 3, or 1. And plugging in 3, we get 2 to the third minus 3, which is 8 minus 3, or 5. Okay? And so we've got some points for ourselves here. Again, I'm going to put them in pencil in case I have to erase. We have 0, negative 2, 1, negative 1, 2, 1, and 3, 5. And we've got our exponential here. Okay? Okay, and so then what part am I going to be leaving? Well, I'm going to be leaving the part where x is less than or equal to 3. Right? If it's not less than or equal to 3, then I'm not including it. Okay, well, all of these values here are less than or equal to 3, right? This is like x equals negative 6, negative 5, right? Negative 4, negative 3, negative 2, negative 1, 0, still less than 3. 1 still less than 3, 2 is still less than 3, all the way to x equals 3. And then is this a point or a no point? Okay, well, again, there's an equals, and so this is a point. If there was no equals here, if it was just a less than or a greater than, it would be a no point, and so I'm going to put a point at x equals 3. And then erase everything on the other side, because that's stuff like at x equals 4 and x equals 5, stuff bigger than 3. And you've got your piecewise, or at least part of your piecewise. Okay, and then review, domain and range. Okay, domain, what x values do we touch? And when we start out here at negative infinity, there's an arrow. And we keep going, keep going, keep going, keep going until 3 when x stops. So we're going from negative infinity to 3. We never use a bracket on negative infinity or infinity because there will never be a point there. And then at 3, because there is a point, we are using a bracket. Okay, what about range? What's the lowest range we hit? Well, looks like negative 3 is the smallest y I have. And then it goes up. There's points all the way until y equals 5 when the graph stops. At y equals negative 3, is there a point? Nope. It's an asymptote. What about at 5? Yep. And so that's a bracket. Okay. Okay, let's go ahead and move down to number 5 next. Okay. Number 5. We have 2 pieces to this piecewise, and so let's go ahead and take the top one first. No, never mind. I'm going to do the bottom one first. That's just 4, right? That one's pretty easy. What does y equals 4 look like again? Remember, a y equals 4 is a horizontal line. And so, again, let's go ahead and put this in pencil. 1, 2, 3, 4. Here's my horizontal line through y equals 4. Okay, and then what part of it are we keeping? Well, for y equals 4, we're only keeping what happens between x equals negative 3 and x equals 1. Right, this section right here. Okay, and then at each of those endpoints, is there a point or is there no point? Okay, what, negative 3? There is a point. There's an equals. At 1, there is a no point. No equals. Okay, so we're going to put a point at negative 3 and a no point at 1. A hole there. Zoom in a little bit. My hole starts to look a little bit filled. I do want to make sure we see that there's no point there, right? That's an open circle. Sorry, my line went a little bit into it, but that is an open circle. Make sure that's clear. Okay? Okay, and then next up we have our quadratic. Okay, so I'm going to rewrite our quadratic over here. Y equals -1/3 x minus 3 squared. Okay? So go ahead and, it's already in descriptive form, so what is my starting point? Okay, well, to zero out the x would be 3. To zero out the y would be 0. So my starting point is at 3, 0. Right there. Okay, and then how are we graphing? What is our a? Okay, our a is -1/3. And remember with the quadratic, it's down 1/3 over 1. So down 1/3 over 1. Okay. And so I'm going to do a little sketch here initially. So we're looking at something like that. Question is, what part of that quadratic are we keeping? Okay. Well, we are keeping everything that is greater than 1. So anything that's less than 1, so like this little piece here, I am not going to be keeping. Okay? For those who are starting to kind of process the proportions involved in a quadratic, you may know where x equals 1 exists on this quadratic. For those who aren't processing the proportions of it, you might want to just real quick plug that 1 in and see what you get. Right? Just so you have an ending point here. And so when I plug in 1, I get 1 minus 3, which is -2, squared, which is 4, times 1/3, which is -4/3, or -1 1/3. And so my 1 is kind of stopping right here. Okay, so something roughly speaking like this, right? And then coming down here. And then at 1, are we, do we have a point or no point? Okay, well, there's no equals, so there's no point. This is an open circle here. Okay, and then domain and range. Okay, domain, the smallest x we have is out here at -3, where there is a point, so we have a bracket. And then we work our way across, and right here at x equals 1, we notice that nowhere on this graph at x equals 1 do we have a point, right? We have a hole here and a hole here. There's never a point. And so I have to cut at x equals 1. There is no point. And I'm going to do a parenthesis for no point. Okay, and then it picks up again at 1. Again, no point, so I've got a parenthesis. And goes all the way to infinity. It's tempting, by the way, to want to say negative infinity here, but remember the negative infinity is the range, right? The going down like this, down is a y measure, not an x measure. And so make sure you're saying infinity, because while this goes down, the graph is also going right. And right is a positive x value, right? These are positive x values over here, so this is positive infinity. Range, on the other hand, my lowest y is negative infinity because that arrow is going down. And then I work my way up, work my way up, work my way up. My graph initially stops at 0, where there is a point. So let's go ahead and cut it there. And then picks back up again at y equals 4, where there is a point. Okay, and then this may be the first time you have seen this. There are actually 2 ways of writing this range here. Because it starts and stops at 4, you could just put a bracket on the other side like that. Okay? Or you could write it starts at 4 and ends at 4. And so you could write it like that, right? That my lowest and highest range after this initial interval, both of them are 4. So either one of these are acceptable. Okay, we are going to do 2 more. If you feel like you've got this, or I would encourage you, even if you feel a little bit uncomfortable, pause it, see how far you can get on your own, and restart the video when you're ready. That way you're getting that gauge, right? What am I actually understanding? Where are my questions in this? Don't just follow along blindly. Don't write things down blindly. We need to be thinking about it, right? So I'd encourage you to pause it, try it. Okay? Let's go ahead and come back up here to number 4. Okay, number 4, first up, we have our exponential here, 3 to the x plus 1. What is my starting point? Okay, my starting point would be -1 for x and 0 for y. And remember, that's your asymptote at -1, 0. And then 2 other values. I'm going to plug in -1 because that's what I already have. Looking over here, -1 is also the number that they have identified. So since I'm already plugging that in, I'm obviously not going to plug it in again. But say this was like 2. Well, I might plug in 2 as well. But in this one, I'll go ahead and plug in 0. Okay, plugging that in. -1, we have 3 to the -1 plus 1, which is 0. And 3 to the 0 is 1. And plugging in 0, we get 3 to the 0 plus 1, which is 3, and 3 to the first is 3. And so I've got 2 coordinate points here, at -1, 1, and at 0, 3. And so I've got my little exponential. Okay, what part of that exponential am I keeping? Okay, well, only that stuff that's greater than or equal to -1. So I'm not keeping any of this stuff over here, right? Only stuff greater than or equal to -1, so the stuff on the right. And then do we have a point at x equals -1 or a hole at x equals -1? Okay. Well, there's an equals, so that's a point. Okay, next up we have our absolute value. Let's write that over here. Now this one does need to get turned into descriptive form, so take a moment. How would I turn this into descriptive form? Okay, I'm going to subtract 3 to the other side. Okay, what's my starting point then? It'd be -2 for my x and 3 for my y. So -2, 3. And what's my slope? Okay, well, my slope is -2, so that's down 2 over 1, down 2 over 1. So we get this graph here. Okay. Okay, what are the parts of this absolute value that you're keeping? Okay, well, we're keeping everything less than -1. So that means all this stuff over here is going away. Only the stuff less than -1. I drew that pencil a little dark. Remember, keep it light because you're going to be erasing some stuff. And then is there a point or a hole at -1? Okay, well, here there is no point, so a hole. However, this is a little bit funny. Notice where my x equals -1 on that absolute value lies. It lies on the point for my exponential, and so there's not really a good way to show that there would be a hole there. There's already a point, so the place where you would draw a hole has been filled in. But say this had been slightly above that y equals 1 or slightly below that y equals 1, you would have drawn an open circle. Okay, domain and range. Okay, domain, what is your domain here? Well, my smallest x is negative infinity. And then remember, never a bracket. Working my way across, there is never a break in this graph, never a place where I don't have a point, all the way to infinity. Okay, what about my range? My lowest y is negative infinity, and working my way up, there's a point everywhere that there's a y equals 1, never a hole, never a break, all the way to infinity. Excuse me. Okay, last one, number 6. Again, I encourage you to pause the video, see how much of this you can get down on your own. That way you can figure out where your questions are. Okay, first up we have our y equals 5. Okay, well, what does y equals 5 look like? It's a horizontal line through y equals 5. It's like that. And then what part of that line am I keeping? Keeping everything where x is less than negative 3. So starting here at negative 3, everything that is less than negative 3. Okay, is there a point or no point for this negative 3? Okay, well, this would be a no point. There's no equals. So we're going to do a hole here at x equals negative 3. Okay, next up we have our y equals 2x plus 1. For those who are comfortable graphing in slope-intercept form, go ahead and do so. For those who would rather turn it into descriptive form, we're going to walk through that together. What would I do for descriptive form? Okay, I'd subtract 1 to the other side. What would my starting point be? Okay, well, x would be 0, y would be 1. Whoops, I forgot to erase the part of the line I'm not keeping up here. Okay, 0, 1. And what would my slope be? Okay, well, my slope would be 2. So up 2 over 1. Okay. So I get this graph here. Again, keep it light because you're going to end up erasing some of it. Okay, what part of that line am I keeping? Okay, well, I'm keeping everything between negative 3 and 1, which is starting here and ending here. Everything from negative 3 to 1. I should say everything from x equals negative 3 to 1. Okay, point or no point? Okay, well, both of these have equals, and so both are points. Got a point at x equals negative 3 and a point at x equals 1. Okay, last but not least, our exponential. Turning it into descriptive form, what would we do? Okay, we'd add 2 to the other side. What's your starting point? Well, x would be 0, y would be negative 2. Remember, that's your asymptote, 0, negative 2. Okay, 2 additional points here. Okay, I'm going to plug in x equals 0 because I already have that. And I'm also, because 1 and 2 are given for this function, I'm going to go ahead and plug 1 and 2 in as well. Right, because for some reason they're important. So might as well have their y values. Okay, when I plug in 0 to my function here, I get 1/2 to the 0 minus 2, which is 1 minus 2, or -1. Okay, when I plug in 1, I get 1/2 to the first, which is 1/2, or 0.5, whichever one you prefer, minus 2, which is either -3/2 for those who like fractions, or -1.5 for those who prefer decimals. And then plugging in our 2, we get 1/2 squared, which is 1/4, or 0.25 minus 2, okay, which is either -1 3/4 for those who prefer fractions, or -1.75 for those who prefer decimals. Okay, and so we've got some points here: 0, -1, 1, -1.5, 2, -1.75. So we've got our little exponential here. Okay. And then what part of that exponential are you keeping? Okay. Everything between 1 and 2, which means this is just between 1 and 2. We're just keeping this little segment right here. Well, not a segment. It actually does curve. And so we're going to be erasing everything else around that little piece there between 1 and 2. Okay? And then point or no point? Okay, well, there are no equals, so it's no point. So we have a hole at both of them. Okay, last bit. One more practice here in this set of notes, domain and range. Okay, so domain first. What is the smallest x we've got? Okay, well, I've got an arrow here pointing to the left, so I'm starting at -infinity, which remember is always a parenthesis. And then working my way across, I hit x equals -3, and you might momentarily go, oh, there's a hole. I have to break it. However, there isn't a lack of point at x equals -3, right? We actually do have a point at x equals -3. It's different than this one up here, right? Where when I hit x equals 1, I didn't have a point anywhere, and so I had to break it there, right? X equals 1 doesn't exist for this function. There's never a point at x equals 1. Down here, though, there is a point at x equals -3. It's just located down here, so I'm going to keep going. Right? I hit x equals 1, pop down here, right? There's still a point at x equals 1. It's right here, so I'm going to keep going until x equals 2, where my graph stops. There is no point at x equals 2, and so it's a parenthesis. Okay, for range, what's the lowest y you hit? Okay, our lowest y is down here at -5. And there is a point, so that's a bracket. Okay, then working our way up, we have points, point, 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 keep having points. There's this little weird thing over here, so this is not 1 to 1, right? But there's still points. Y equals points all the way up, y equals points. Oh, and then there's a space here. There's a break where we lack points, right? So the last place I have a point is at 3. And there's a point there, so that's a bracket. Again, if it was a hole, I would put a parenthesis. And then this picks back up again at y equals 5, where we do have points, all these points here. And then again, you have two ways you can write it, like example 5 up above, starting and ending at 5, or just 5 inclusive. Okay, again, if there are questions, write them down.